Greenhouse gases. What are the trends in greenhouse gas emissions and concentrations and their impacts on human health and the environment? Importance of greenhouse gases. Other factors affecting climate change. Greenhouse gases and their sources. Impacts of climate change. ROE indicators. Importance of greenhouse gases. Greenhouse gases, such as carbon dioxide, methane, nitrous oxide, and certain synthetic chemicals, trap some of the Earth's outgoing energy, thus retaining heat in the atmosphere. This heat trapping causes changes in the radiative balance of the Earth, the balance between energy received from the Sun and emitted from Earth, that alter climate and weather patterns at global and regional scales. Multiple lines of evidence confirm that human activities are the primary cause of the global warming of the past 50 years. 1 Natural factors, such as variations in the Sun's output, volcanic activity, the Earth's orbit, the carbon cycle, and others, also affect Earth's radiative balance. However, beginning in the late 1700s, the net global effect of human activities has been a continual increase in greenhouse gas concentrations. This change in concentrations causes warming and is affecting various aspects of climate, including surface air and ocean temperatures, precipitation, and sea levels. Human health, agriculture, water resources, forests, wildlife, and coastal areas are all vulnerable to climate change. Many greenhouse gases are extremely long-lived in the atmosphere, with some remaining airborne for tens to hundreds of years after being released. These long-lived greenhouse gases become globally mixed in the atmosphere, and their concentrations reflect past and recent contributions from emission sources worldwide. Others, like tropospheric ozone, have a relatively short lifetime in the atmosphere. Other factors affecting climate change. In addition to greenhouse gases, other related factors, including other radiatively important substances and albedo, can alter the Earth's climate. Other radiatively important substances. Certain substances are technically not greenhouse gases due to their physical state, but they nonetheless affect the Earth's energy balance. Some of them, such as sulfate aerosols, have negative radiative forcings that can lead to cooling effects. Others, such as black carbon or soot, contribute to warming. Albedo. Albedo is the amount of solar radiation reflected from an object or surface, the Earth's surface, in this case. Natural and human factors can affect albedo on a global scale, through changes in large-scale features like the polar ice sheets, or on a local or regional scale, example, by increased amounts of dark paved surfaces that absorb energy versus light paved surfaces that reflect energy. Although this ROE question does not address radiatively important substances or albedo, both factors are important to understanding the planet's energy balance and the ways human activities may affect that balance. 2. Greenhouse gases and their sources. Some greenhouse gases are emitted exclusively from human activities, example, synthetic halocarbons. Others occur naturally but are found at elevated levels due to human inputs, example, carbon dioxide. Anthropogenic sources result from energy-related activities, example, combustion of fossil fuels in the electric utility and transportation sectors, agriculture, land use change, waste management and treatment activities, and various industrial processes. Major greenhouse gases include carbon dioxide, methane, nitrous oxide, and various synthetic chemicals. Carbon dioxide is widely reported as the most important anthropogenic greenhouse gas because it currently accounts for the greatest portion of the warming associated with human activities. Carbon dioxide occurs naturally as part of the global carbon cycle, but human activities have increased atmospheric loadings through combustion of fossil fuels and other emission sources. Natural sinks that remove carbon dioxide from the atmosphere, example oceans, plants, help regulate carbon dioxide concentrations, but human activities can disturb these processes, example, deforestation, or enhance them. Methane comes from many sources, including human activities such as coal mining, natural gas production and distribution, waste decomposition in landfills, and digestive processes in livestock and agriculture. Natural sources of methane include wetlands and termite mounds. Nitrous oxide is emitted during agricultural and industrial activities, as well as during combustion of solid waste and fossil fuels. Various synthetic chemicals, such as hydrofluorocarbons, perfluorocarbons, sulfur hexafluoride, and other synthetic gases, are released as a result of commercial, industrial, or household uses. Many other gases are known to trap heat in the atmosphere. Examples include water vapor, which occurs naturally as part of the global water cycle, and ozone, which occurs naturally in the stratosphere and is found in the troposphere largely due to human activities. Each greenhouse gas has a different ability to absorb heat in the atmosphere, due to differences in the amount and type of energy that it absorbs, and a different lifetime, or time that it remains in the atmosphere. For example, it would take thousands of molecules of carbon dioxide to equal the warming effect of a single molecule of sulfur hexafluoride, the most potent greenhouse gas, in terms of ability to absorb heat, as evaluated by the Intergovernmental Panel on Climate Change, IPCC, Point 3. To facilitate comparisons between gases that have substantially different properties, the IPCC has developed a set of metrics called global warming potentials. Learn more about greenhouse gas, GHG, emissions. Impacts of climate change. The changing climate affects society and ecosystems in a variety of ways. For instance, a warmer climate is expected to both increase the risk of heat-related illnesses and deaths and increase certain types of air pollution. More severe heat waves, floods, and droughts are expected in a warmer climate. These may reduce crop yields. Sea level rise could erode and inundate coastal ecosystems and eliminate wetlands. Climate change can alter where species live and how they interact, which could fundamentally transform current ecosystems. These and other aspects of climate change are disrupting people's lives and damaging some sectors of the U.S. economy. Point 4. This has led many state and local governments to prepare for these impacts through adaptation, i.e., planning for the changes that are expected to occur. ROE indicators. The ROE presents 6 indicators showing trends in greenhouse gas emissions and their associated environmental impacts: greenhouse gas emissions, greenhouse gas concentrations, energy use, temperature and precipitation, sea level, and sea surface temperature. Emissions. For several greenhouse gases, the nation's estimated combined emissions that are directly attributable to human activity have increased 7% between 1990 and 2014. Fossil fuel combustion is the country's major source of anthropogenic greenhouse gas emissions. Concentrations. Data on atmospheric concentrations of greenhouse gases have exceptionally long historical records, with data for some gases spanning several 100,000 years. For carbon dioxide, methane, and nitrous oxide, the historical context provided by ice cores shows that present atmospheric concentrations are unprecedented over the last 800,000 years, and demonstrate that the recently increasing levels reflect the influence of human activity. Impacts. The indicators present compelling evidence that many fundamental measures of climate in the United States are changing. Average temperatures across the contiguous 48 states have increased since 1901, with an increased rate of warming since the late 1970s. Total annual precipitation has increased in the United States and over land areas worldwide. Since 1901, total precipitation in the contiguous 48 states has increased at an average rate of 0.17 inches per decade. Ocean surface temperatures increased around the world during the 20th century, and the average surface temperatures during the past 3 decades have been higher than at any other time since widespread measurement began in the late 1800s. Finally, when averaged over all the world's oceans, sea level has increased at a rate of roughly 0.6 of an inch per decade since 1880, and the rate of increase has accelerated in recent years to more than an inch per decade. Information and compelling evidence on a much broader range of climate change impacts can be found in EPA's Climate Change Indicators in the United States and the scientific literature. There are a few limitations associated with the ROE greenhouse gas indicators. Emissions. The emissions trends are based largely on estimates, which have uncertainties inherent in the underlying engineering calculations and estimation methodologies. Uncertainty in emissions estimates varies among the gases and sources, though estimated emissions from some of the largest sources, example carbon dioxide emissions from fossil fuel combustion, are considered highly accurate. 0.51 gap in the emissions indicator is that EPA's greenhouse gas inventory does not track every greenhouse gas or every emission source. Examples of greenhouse gases not included in the inventory are ozone and selected chlorofluorocarbons. The most notable sources not tracked in the inventory are natural sources, such as methane from wetlands, carbon dioxide and methane from thawing permafrost, and multiple emissions from volcanoes. Concentrations. While the concentration data thoroughly characterize trends for carbon dioxide, the most important anthropogenic greenhouse gas, and other extensively studied gases, comprehensive global data are not available for other radiatively important substances, such as soot and aerosols. Though these substances technically are not greenhouse gases, tracking trends in these substances' concentrations is important due to their ability to alter the Earth's energy balance. Impacts. The changing climate can affect society and ecosystems in many ways. For example, climate change can alter the likelihood of extreme weather events, influence agricultural crop yields, affect human health, cause changes to forests and other ecosystems, and even impact energy supplies. ROE indicators were developed for a few climate measures that are most directly linked to greenhouse gas emissions and concentrations and that have particularly long and abundant records. Information on a much broader range of climate change impacts can be found in EPA's Climate Change Indicators in the United States and the scientific literature. References. 1. Melillo, J.M., T.C. Richmond, and G.W. Yohe, eds. 2014, Climate Change Impacts in the United States, the Third National Climate Assessment. U.S. Global Change Research Program. 2. Detailed information on these related factors can be found in various scientific publications, such as those prepared by the Intergovernmental Panel on Climate Change, a panel formed by the World Meteorological Organization to compile and synthesize the growing body of scientific literature on climate change. 3. Intergovernmental Panel on Climate Change. 2013, Climate Change 2013, The Physical Science Basis. Working Group by Contribution to the IPCC Fifth Assessment Report. Cambridge, United Kingdom, Cambridge University Press. 4. Melillo, J.M., T.C. Richmond, and G.W. Yohe, eds. 2014, Climate Change Impacts in the United States, the Third National Climate Assessment. U.S. Global Change Research Program. 5. U.S. Environmental Protection Agency. 2016, Inventory of U.S. Greenhouse Gas Emissions and Sinks, 1990 to 2014. EPA 430 R16-002.